Well, let's go ahead and get started. I'm not sure that Alma is going to make it, but we're recording, so she can benefit from that. So I'm going to turn the time over to Riley and Abu for helping with kind of putting maps in and managing spatial data for generating maps in web applications. So go ahead, I'll let you two take it away.
Okay. So.
Oh, perfect. Here comes Alma.
Oh, good. We got everyone.
Hey, I'm here now.
Yep. It's a good thing we started. That's what made you come, I'm sure.
Yep. Sorry about that. I had to move locations.
You're totally fine. Go ahead, Riley.
Yeah, so like Dr. Nelson was just saying, that the major takeaway from this lesson is you should know about like web services, specifically how we make web maps and how you can show spatial data, and then at least be familiar with what other kinds of web services are. I probably got carried away and wrote too much about just in general what web services are. But I felt like it was important to establish that web services is more than just what we say that a service is in here. Because when I was first getting into the lab, people said service this, service that, and I was very confused what it all meant. So hopefully by spending some time on explaining just a bigger picture of what web services are, you can avoid some of that confusion and understand when we say service, it means it's a general thing and we're referring to some specific software or some specific instance of what web services are. So let me pull up the lesson documents. See, we've got, it's under background where I wrote all of that. Did anyone, just to start, did anyone have questions over any of the lab, or not lab, the lesson that we can start?
To be honest, I actually didn't. What's the topic today? I didn't look at the cohort schedule for this week or for this time, and so I actually haven't read whatever one we're doing today.
And my guess is, Riley, maybe a lot of them haven't done it yet. So.
Oh, okay.
Kind of just at the tail end, barely, and with finals coming up, with some taking classes.
That's right.
I think most people are at the cusp of doing this if they haven't started it, but probably not everybody's done through it, and so you might need to kind of preview as much as review.
Okay. Yeah, no, that's good context for me. So how many of you have read through the lesson just at all? Any amount of it?
About 3/4 through.
Cool.
I read through, yeah, about 3/4 of them.
Okay, so we've got a couple people that have been through, but looks like most of you have not. That's all right though. I think I'll start by sharing my screen then, and we'll go over part of the lesson together. All right, you should all see my Chrome browser, right?
Yep.
Great. So the topic is web services. This, like I was just saying, I get kind of carried away explaining the big picture view of what web services are, and that's probably then what's the most important thing for us to spend time on now, and then Abu will cover the different sections that come later in the lesson. Maybe it'd be a good idea to just read through the background section together then. Yeah, I was expecting more of a review. Sorry, so I'm making this up as I go now. So yeah, I'll read through the first couple paragraphs. So it says, in the world of computing, there are some important challenges that have been around since the beginning of computing. You've probably thought about these challenges and just not known them. When you bought your computer for school, like you had to figure out, do I have enough hard drive space? Do I have enough? Is the processor strong enough? Is there enough memory? And even if you didn't know what all of those meant, you've probably heard all those terms before. And you're trying to figure out, is it going to be enough for me to run my engineering software and so forth. And so the traditional way of solving that is you buy a really strong computer and you do it all yourself. You build from scratch. You're responsible for writing all your own code, installing all your own software, so forth. The kind of new hydroinformatics-y applicable solution to this is called web services, or service-oriented architecture. You'll hear a lot of terms, but it's all getting at the idea that you don't have to be primarily the one responsible for solving all of these problems. A web service is a way that computers can communicate with each other to get a specific job done. So you don't have to worry about, like, do I have enough RAM to run this program? Do I have enough whatever to run my hydrologic model or my hydraulic model or something like that? Services almost always have some kind of standard associated with them. And let's go right into I should also say, when you create a web service, they use the term implemented, and when you use a web service, it's called consumed. It's just the computer jargon for it. So I wrote this little analogy thing to try and explain what I mean by all of this, because it's important to understand that there are some different parts here. So suppose someone gives you a business card, and there's some standard things that go on a business card. It's going to have your name on there, and then you're probably going to see a string of 10 numbers that's formatted like this, and you're going to know right away that that's a phone number. And then there's probably another line that looks like this, and you know immediately that that is an email address. And without ever having someone tell you, without a label or a picture or something, you just know that's a phone number and an email address, because you know that there's the standard way for you to convey a phone number is you write it like this. And the standard way for you to tell someone what your email address is to write it like this. You could say the same thing about, like, your Twitter handle. You use the @ and then your Twitter username, or a LinkedIn profile. They all have that standard format for how you write it. And so the big picture service there would be phone calls or emails. And you know that in order to use the service of emailing and phone calls, there are specific things you have to do. You have to have a phone, you have to pay the phone bill, and I shouldn't skip ahead. Let me read this part. So the services that we just described are phone calls and emails. They're ways that you get the computer or the phone to share your words or voice with another computer or phone. And so they accomplish the task of letting you communicate with someone else, and you use that so that you don't have to write, letters or drive to someone's house and talk to them or whatever. And it makes your life simpler that way. You don't have to write a website chat room. You can just send them an email. And one of the standards associated with phone calls is the formats for writing the phone number and email. There's lots of different options for ways to send emails. You can use Gmail, Outlook, Yahoo, And you know that those are ways that you can send and receive emails, but they are not the service of emailing. Saying that you use Gmail to send emails, you don't say Gmail is emailing. And same thing with phone calls. You have to buy a phone, you have to pay for your service from T-Mobile and Verizon or whoever, but your iPhone isn't phone calling and T-Mobile isn't phone calling. They're just different components. You have to have hardware and software, like an account somewhere, in order to use all of them. So the big recaps from this are: a web service is a way that you can get a computer to communicate with another computer. You do that to make your life easier so that you don't have to do all the work yourself. Web services always have a standard associated with them, so like a file format or a format for writing the phone number, something like that. You usually need a specific kind of software and hardware to use it. So like you might need a Google account, or you might have to have specifically a Linux computer or something like that. There's some certain amount of required software and hardware. Anyone can make a web service. Like there are different kinds of software and hardware you can use to create or use web services. So the specific examples that we'll give later are not the only options. There are lots of options for using the web services that we'll talk about. But you do have to use the correct standards and the right software and hardware. Those are required. And related to that, web services are intended to be kind of modular and interchangeable. You have to have all the required parts, but it doesn't have to be like if Esri makes ArcGIS, that's not the only way that you can use GIS. You can do it in other ways. But their web services are intended to be like, you can't share Esri products with non-Esri software. A web service is intended to be different, that you can share it with everything without having to buy a specific set of softwares or something. So does that kind of make sense, that there are web services are this concept and they have different components and standards? Does anyone have questions about that? I'm going to take that as a no. All right, well, let's, I guess, keep going then. So the first two web services that we'll talk about are cloud computing and software as a service. Cloud computing is a kind of web service that the scenario I give right here is, suppose we build a really big hydrologic model like the GeoGlows ECMWF streamflow model. That takes a really, really, really big computer to run it on, and we don't want to have to buy that computer because it would cost $1 bajillion, and we don't want to have space in the lab to set it up or whatever. We don't want to have to worry about making sure we have enough internet and the power doesn't go out at BYU, and which I feel like happens all the time in our lab for some reason. But we don't want to do all of that. So the web services kind of approach to this is called cloud computing. Instead of me needing to go out and build all of this myself, I can just rent the use of someone else's computer. Effectively, that's what it is. I'm renting the use of someone else's computer. And then I can only pay for it when I want to use it. I don't have to worry about it always being maintained. And if something breaks, the people that I'm renting the computer from fix it. And the common ways that we use that around here are, it's called Amazon Web Services. Usually they just call it AWS, or Microsoft's version of it is called Azure. And we use both of those in the lab. There's really not like a tutorial or anything for this. you should just be aware that that's a web service that the longer you're here, you're more likely to have to build some kind of cloud computer for. Software as a service is another way to do that. Instead of me needing to buy all the licenses and set up computers or whatever for me to run engineering software on, a web services approach to doing this is called software as a service. And BYU, well, actually the engineering college actually does this. You can use software as a service through Citrix. If you haven't done this yet, you probably will for some of your classes. You go to this link, and then depending on which kind of computer you're on, it'll take you to this Citrix page, and you log in with your KDM username and password, and then from your browser, you can control software. That saves you the hassle of needing to set it up on your own computer. That's useful if you don't want to pay for the licensing and whatever. So that's another common example. Then Abu is going to take over and talk about OGC web services. Yeah, so I'll let Abu take over.
Cool. I can just use your screen, like, you can just share your screen and I can use it from there.
Okay.
So yeah, I'm going to talk about like mapping components, especially first. And do you want me to do that first, or do you want me to go ahead with OGC?
However you want to do it. I don't think
Okay.
it matters to me.
Perfect. So on page, yeah, could you slide to mapping components, really, after the appendix?
Oh, down here. Down here, this stuff.
Yeah, just a little bit about. So yeah, in our Tethers apps, we use maps, and we use dynamic maps for in these apps. And the reason why we use these maps is because we want to do some geospatial analysis, or like some statistics. So we just want to study the geography of an area, the rivers, hydrology, and all of it. In order to accomplish that purpose, we have these options called open dynamic maps. Some simple ones which I have used and which I prefer are open layers and leaflet, and that's what I've written about in the document. Open layers is one type of a dynamic map, and leaflet is a bit lighter. It's just like 38 kilobytes, so it's pretty light. And open layers is a bit older too. I prefer leaflet more because that's what I used in my app, but they're nearly the same thing. So open layers, as you can see here, it has been developed to use geographic information of all kinds. And so we have different kinds of options. There's like tile layers, vector layers. Vector layers, you can use data from GeoJSON and KML, GML, and all of these things. And we can also link it to Mapbox, which is very good for moving and retrieving information from. And we also have, okay, yeah, I've given like some tutorials in the bottom. This tutorial is a very simple walkthrough for you to try this out in your HTML script. So you can just open a random HTML file and you can just paste all of these lines of code. And once you save it, it should open up as a website that has a dynamic map on it. And the steps to do these are pretty simple and very easy to understand. So I don't think you'd have a problem, but if you do, you can always reach out to me and I'll help out. Leaflet is, as I said, a dynamic mapping service. And I like Leaflet more because it's a bit simpler to understand, and I have run into lesser bugs in Leaflet than in open layers. So Yeah, and their tutorials is even more simple than open layers, because they give you very simple CSS options to style your map. And yeah, you could try this on your own, and it won't take much time. I've given a small snippet of markers, circles, and polygons, which is for you to customize your map. Let's say you want to place a marker, or you want to highlight a radius of your map, and you could do that just like how you place a pointer. And so the marker, and so the markers and circles and polygons is very similar in their procedure. And I've also like added links to the documentation to the actual website, so you can, if you want to know more about both of these, you can always click on them. And there's also like few other things that the leaflet offers, like the API reference. You can see there's a map, there are UI layers, there's things that you'd want to do, like control the zoom. That's something which I was working on, and I asked even Riley's help for a bit on trying to maximize and minimize with automatic zoom controls. And it's pretty simple in leaflet. And you can also move your lat long bounds. That's pretty flexible too. So you can do all of these things. Like it's open source, and you can just enjoy it. If I've like, I've added the link into these tutorials, so yeah, you can try it for yourselves. And what else, Riley? OGC?
Yeah, we should talk about the OGC services for web mapping service, tile mapping service, and things like that.
Okay. Yeah, before I go into that, is there any questions for anyone, like with respect to open layers or leaflet? Okay, I'll take that as a no. So OGC is actually Open Geospatial Consortium, and is a service for publishing of geospatial processes, algorithms, and calculations. As Riley was saying, this is not the service itself, but we can access these services through different mediums. And like, for example, you can see the Hamas, I don't know how you pronounce this name, but yeah, so that's one way of using it. That's one way of accessing. Like, correct me if I'm wrong, like, but.
So hydrologic modeling as a service is not an OGC thing. So OGC is this group of like it says here, it's just all kinds of agencies, governments, companies, universities, and they got together and said, we need to come up with a service-oriented way to help people share GIS data. So the OGC itself is not a web service, it's a group of people, but they created some important like concepts for web services, namely web mapping service, web coverage service, and web feature service, which, yeah, that I'd start there, I think, Abu.
Yeah, I mean, you can take over. I think you have a better understanding of this, so yeah, I'll leave it to you.
Okay. So getting back to what the main inspiration for web services is, so that it makes it easier for you to use things that would otherwise be complicated for you to write your own softwares for. So leaflet and open layers, let me pull up an example here. So if I open up one of our apps, let's say this would be a good example. So here's a map. Leaflet is a software that was used to create this map. And if you look here, I've got a bunch of different kinds of data on here. and I can toggle them on and off. I can put a points on the map, and that would be analogous to like a shape file that contains a point. And if I click on one of these countries, let me specify just one. Like let's do Mexico. If I type in Mexico, this boundary for Mexico is a shape file that contains the big main body of Mexico plus a couple islands, it looks like, but that's polygon data. And the problem here is that JavaScript and HTML doesn't know how to read shapefiles. So instead of you building your own brand new complicated way to make your JavaScript read a shapefile so that you can put it on your map like this, there are OGC created this concept of services, web mapping service, web coverage service, and web feature service. And so what that does is you create, the idea is they'll create these services that solve the problem for you. Specifically, these are actually very good descriptions that Abu wrote here. I'd recommend going back and reading those when we have more time. So how did I, oh, oops, press stop sharing an accident. So on Zoom toolbars covering my tab. Okay. So the way that we got this shapefile data to show up on the map is using a web mapping service. What that does is instead of giving your browser a shapefile, which JavaScript is not good at reading, we know JavaScript is really good at getting pictures. So you can use a web mapping service on any kind of spatial data, raster or vector, and you get back the service provides you a picture, which JavaScript and HTML are very good at handling. So this, going back to my app, I should just close that tab so I stop clicking on it. This polygon is not actually a shapefile, and this raster layer is not actually a geotiff or any of the formats you're used to working with raster data in. This is a JPEG of what my data looks like, so that I can use it easily in my web map. But because it's a picture, that means that this polygon doesn't have its attribute table, and there aren't actually numbers. Like if this were a DEM, I can't actually like click on the pixel and get the elevation value where I clicked. So that's a problem. Web mapping service lets me convert my geospatial data into a picture, which I can show, but then when I want to make my map interactive, I don't have a way to get at the actual information that it contains. Like I can't buffer or clip a picture. So a solution to that, they did them separately. A web coverage service is how you do it for rasters, and a web feature service is how you do it for vector data. But what it does is it just takes the GIS data that you give it, and it essentially makes a new website. So when someone clicks on the map, it doesn't know that this polygon corresponds to Mexico, but what it did is it just went to the website that my web service created, and it's that website has tables of all of the information that would otherwise be contained. And one of those attributes is what's the name of this polygon. In this case, it's Mexico. So I click on it, and then it goes to that URL and says, what's the name of this polygon, finds that column in the table, and then plugs it into my button right here. So by combining all of these things, you can kind of fake your way into having a GIS software like ArcMap or QGIS, but in just a website. Does that make sense? this is a big concept, so if there are no questions, we probably did not explain it well enough to you.
I thought it was very helpful, Riley, to explain, especially the idea that the geographic data is converted to an image for the display purpose in a map. That's what's happening with all of this. And so I think that's the important concept or takeaway at this point. That, along with the fact that these are generated as standards, so that you can count on them to be, them to operate the same across different operating systems or different applications, can develop their GIS web mapping stuff so that it functions in this way. But I want to hear from you, students. Do you understand this? Or is it just like way over your head at this point? Or what questions do you have?
I think the explanation Riley gave was a good one. I guess, do you have to, is a lot of that structure, I guess, in place, and you just, I guess, how do you implement that, with clicking on this and then it links to this other page and then it looks up the table? Is that all kind of taken care of in a certain structure that you just have to kind of plug in different elements?
Mm-hmm.
Okay.
So like I was saying, they have a URL. I can show you. View/GeoServer. GeoServer is the name of the software that we use to create web mapping services and web feature services and all that. So if I click on this, these are just a bunch of different shape files and rasters that we've uploaded onto here. And then I can pick, these are the different formats that I can get a WMS image and say, and just like I was explaining, you get a picture back. And if I go PNG, this is a points shape file. And this URL that it just generated for me right here, if I give that to leaflets or open layers or ArcGIS or whatever, it will handle all of that for you. The hard part is just uploading your data into a software like GeoServer that will create the web service for you. And then you get this URL out and it will handle all the rest for you. It's complicated if you want to do something special. So like we had to do our own fancy stringing together of web services to make this app work like it does. But that's 99% of it was done for me just by having this URL to a shapefile. Does that answer your question?
Yeah, that does. Thanks.
Any other questions?
I think I'll have questions in the future. I'm just not sure what my questions are at this time. That's my issue.
Yeah, that's okay. I feel like this is a really big concept to like really get.
Yeah. But I know who to turn to when I do have those questions.
All right, well, web processing service is the other one that we should cover. So in ArcGIS, you make those model builder workflow. Actually, not all of you have probably taken 414 yet. But in ArcGIS, when you do your operations like buffer and clip and whatever, there's a way for you to string all of those together in a pre-configured order so that you can give it, if you know you always need to clip and buffer your shapefile or something, they have these workflows that you can create that will do a series of GIS steps for you. And again, when I'm building a web map like this, I want to be able to do GIS things, but JavaScript can't do that, just like it can't read the shapefile. So the OGC created a standard way for you to run a that series of GIS operations on a server like GeoServer, or there's a whole bunch of different ways that you can do it. Where did the document go? Here, so again, it has a lot of the same things as for the web mapping service. It depends on you having a URL, and then it's complicated if your web processing service takes more than just a certain shapefile. Then you have to manage uploading and downloading data and whatever. But this is all focused around the idea that JavaScript is good at handling images, and it's good at making these little web maps, but it's not good at handling your GIS data. So you can build some kind of, like, I can draw boxes on my map, or I can have different shape files or whatever, and then I can press run and it will go to a URL, and then I've already set up somewhere else my GIS workflow to run. And then usually the common way that you get a result from your GIS workflow is you get a new shape file out, or a new statistic or something like that. And again, I can't show that on my map. So a common way that you get the results from your web processing service is it will send you instead the URL for a new web mapping service, so that you can just show the resulting shapefile on your map. It's very similar concepts to just doing GIS the same way you do web mapping services and web feature services and so forth. I'm not too, I think I would suggest focus on doing the tutorials. Where's that down here? Do these tutorials that will explain to you how you use web mapping services and other stuff in leaflets, and worry about web processing stuff later, because that's more complicated. And I think even in the lab, we don't often use web processing services. We mostly pre-process our own stuff and just use our web apps to display the results of it. So it's good to know about, but I wouldn't worry too much about it yet. See, the other service on here, only other one is hydrologic modeling as a service. I'm wondering if it's even worth trying to explain this one right now. But it's the same kind of idea as before. Hydrologic modeling takes a lot of expertise to build a model with the different GIS components, like a DEM, and you need land use data and soil type data, and you need meteorology information, like how much it's going to rain and when. And that's a lot of stuff to manage. And so the idea is, what if instead of trying to run the model yourself, you can just get the results, of a hydrologic model? And so that, based on the same idea, just if I had a URL that could give me the results of a hydrologic model instead of me needing to build it myself and run it myself, then I can worry about problems further down the line, like what's the impact? Is it going to flood based on the current weather conditions or something like that? You can't answer that problem until you have a working hydrologic model. So this isn't the important concepts of hydrologic modeling of a service for our lab is that we try to run a global hydrologic model so that we can use it to solve other hydraulics and hydrology problems anywhere that we do work with. So in the same model that we've built with that URL that we've created, we can access hydrology information in Nepal or in Peru or in Mexico, United States, Africa, anywhere you want to go. We have a working hydrologic model, and all it takes to get information from your hydrologic model is a URL. And since everyone's got a web browser, everyone can go to that URL and get information from a hydrologic model. again, that might be a little over your head since not everyone has taken the hydrology class. So if you're lost on that one, that's probably okay for now. You'll become more familiar with it the longer that you're in the lab and get familiar with what we do. Well, that was pretty much everything we have to cover. That was, sorry if that was a lot to take in all at once. Didn't realize that finals and everything had probably kept everyone from reading it, the lesson in advance.
No, that was very good, Riley. And this is helpful, and it's recorded. If anybody ever needs the recordings, I'll try to gather them up now and make them available so that you can come back and reference as you get to working through the tutorials.
Yeah, the tutorials are at the bottom of that Google Doc, and I think it will make more sense to you what a web mapping service and stuff does when you follow the leaflet tutorials and the stuff that Abu wrote. I think it's like everything else, you just kind of have to do it once before it really clicks for you. All right, well.
Thanks, Abu and Riley.
Yeah,
Appreciate
thank
it.
you guys.
Everybody.
Thank you.
Thank you.
Thanks. That was helpful.
No problem.
Yeah, see ya.